So there are ionic bonds, there's metal mixtures, and next is covalent compounds, or the bonds between atoms that need to share atoms in order to make a bond. So as we know from ionic bonds, the valence electrons need to make a level full. So most need the second level to be 4, so they need to have 8 electrons. So certain atoms are going to make these covalent bonds, so they both are filling one of the levels. So for something like sodium, it's trying to get 8, and only has 6, so it's trying to share so it can get 8. So it's going to have to share with 2 other things. There are better examples, but that's the gist of it. If there's a atom with 7 electrons, they're going to share with something that has maybe like one compound like hydrogen, like oxygen and hydrogen combined. So hydrogen gets their 2 electrons, and oxygen will get its 8 electrons. So there's a specific way to actually name these. The number of atoms of that certain... The number of atoms that are connecting to, like in H2O, for example, there's 1 oxygen, there's 2 hydrogen. So what you're going to say, there's only 2 elements being used, but there will be 2 hydrogen because the oxygen is 6, actually. It's not 7. But oxygen will connect to 2 hydrogen. And since there's 2 hydrogen, you're going to say dihydrogen. So the number of atoms decides what the prefix is. 1 is mono, 2 di, actually 3 tri, 4 tetra, and so on and so forth. So something like N2O would be dinitrogen monoxide, because there's 2 of the nitrogen and 1 of the oxide. And it's pretty basic, just like that. And that's honestly about it, other than the physical properties. It has low boiling points. It can easily be manipulated because the bonds just aren't as strong since they're sharing. While on the other hand, the ionic bonds you're giving, so they're going to stay strong. When making complex structures between the atoms, where you have both ionic bonds and covalent bonds, where most likely there's going to be multiple atoms being shared between multiple atoms, and a lot of the times there will be multiple elements, so more than 2. But what's going to happen is to find how to balance out all the valence electrons, you're going to need to know the charge of all of the atoms. And then, so if it's like, let's say, potassium and sulfate, so it's potassium sulfate. Sulfate has a -2 charge, so you're going to need a +2 charge to cancel it out. So you're going to have 2 of potassium, and that will help you cancel it out. There are a lot larger examples, but you can find the amount of charge and make sure that they all cancel out each other, so there is no charge, because they will not be happy if there's charge. And then there are also transition metals. They're going to have oxidation states. Their charge states is fixed when they form compounds with other elements. So calcium forms ions with 2+ charge. And then when it combines, a 2+ charge in the compound does not change, so you need to cancel it out. They're less predictable because they have certain numbers next to them, and you have to know kind of what the number will be based on their charge. And you're going to represent that with Roman numerals. So the amount of Roman numerals the first one has is based on the charge of the second and also the charge of the first. So if it's something with charge 2 and there's another compound with charge 6 or something, you're going to have the Roman numeral 3 to balance that out.